Hello, this is Jin. First of all, thank you for joining me. Um, I'd like to talk about our work, Reining mobile web performance with document and permissions policy. This work is done with a collaboration with Northwestern University and Google. So people use all kind of different devices and all kind of networks to access the web. People like here, we use like fancy devices and network, but there are some people who use web under the severe resource constraints. Across such diversity, the web is often slow even for high-end setting. That's basically because how the web is authored. Modern web has many complex. Modern web has many objects like images, CSS, and JavaScript, and thus it needs to be carefully designed. But in general, developers does not consider about the resource constraints much about the resource constraint at its design step. On top of this, the permissive nature of the web platforms make the situation worse. We do know what is the best performance, but there's no enforcement of the best practices for developers. As a result, web quality of experience is poor. It is poorer for those people who use web with low-end devices and networks like mobile. It is still loading. So this is very important problem because online commerce heavily depends on this. So it has served as a major motivation for both academic and industrial works. So there are lots of solutions about this. So one of the popular example is Google's AMP. And this is also a good example that large companies spend a lot of money on this issue. Google's AMP can help developers to develop performant pages. And we show that it indeed improved performance significantly at OWICOM 2019. This example shows AMP enhance the performance of the original page, and it makes the page more stable. AMP page loading is done, but the original page is still loading. Still loading. Yeah, now it's done. But 6 years later from its first release, its adoption is limited. It's very popular among news pages, but across overall web pages, like Alexa top 10 million pages, the adoption rate is under 0.2%. One of the main reason is people doesn't know like this is the problem. When even if they know the problem, it requires quite a bit of work for developers to adapt, and in the process they often lose the flexibility. So what we want to do is to make users benefit from this performance improvement introduced by AMP or other previous solutions, even for the pages that doesn't follow the best practices. To do this, we need to at least detect violations of the best practices and then identify that best intervention. Intervention, in other words, is how we can change such violation of the best practices into the best practices. And then we can design a solution to apply intervention. In this paper, we explore the viability of this approach. So for the first thing to do, detecting the best practice violations, luckily there is a thing that does this job, named document policy and permissions policy. These are web platform APIs that control browser features. Developers can force browser features work as they initially intended, even for third-party content. This feature/policy varies from simple one like camera, GPS, to the complex one like sync script, unsize media, and so on and so forth. So at this point, some may wonder, so what on earth are you talking about this best practices and its detection? So let me revisit the initial, for example. I'll show the steps of this web page loading. This is a very initial image the user will see when they access the web page. On images added, the title font is changed. Image is gone for some reason, and some other things are added. Image is now back, and a space is secured for advertisement. So I'm pretty sure everybody has this experience, like you want to click a button, but ad comes up, and ad push the button down to the bottom, and you accidentally click the advertisement. This kind of series of layout change does not give any good experience for users. So for this thing, the best practice is like fixing the image size so that the page does not have to change the layout repeatedly. So document policy has a related policy, unsized media there. So it detects any media object that does not have explicit size. So while originally this is aimed for developers, we think this is potential for our performance solution because it is functioning at client side. That means we can identify any violations of best practices at client side without any help from server, proxy, or any other third party. And then we can do something like notifying developers about the violations or enforcing the best practices for users. We see more potential of this. It is browser built-in, so the solution will be very lightweight. And it does not force content providers to change anything immediately. We can do something on behalf of them. So in this paper, we answer these two questions. First one, so do interventions really fix the violations of the best practices? And if so, are such violations of best practices are common in the wild? To answer these two questions, we designed two measurements. The first one is existence proof test with a synthetic page. This shows the improvement indeed exists. Okay. The next test is to check how common the violations are in the wild. And we ran this test with Alexa top pages. We built Chrome extension to control the policy at client side. This Chrome extension changed the policy header of the browser before browsers start processing the responses from server. We chose Chrome because Chrome follows the evolution of document policy very well. Before we dive into the test result, we need to understand the existing policy a little bit. There are nearly 50 different policies. So in the initial assessment, we identified 7 performance-associated ones. The first one is sync script policy. This detects JavaScript that blocked page rendering and block it. I'd note that the major point here is the name of the document policy, and the subpoint is the intervention that currently encoded in the document policy. And unsized media, like the example I showed earlier, detect media without explicit size and set its size to the minimum. Layout change detects CSS animation, which is complex, and shrink the multiple animation steps into the initial and final one, just 2 steps. Font display weight swap detect font which takes a long time to load, and then disable is late replacement. Oversized image block images which is larger than the given container size. and lossy and lossless image max PPP block images as oversized image does, but it detects violation in different way using max bit per pixel. So here's the result. So for the first test, we built a synthetic page that contains multiple objects, and each of which violates one of the policy. So this graph shows the result. Performance improvement introduced by each policy when they are violated, when they are enabled, sorry. So when they're enabled, the associated object is intervened. The red dashed line on the top is the ground truth performance without any policy. So any result below it means improvement. So this shows the front display late swap and sync script policy improve performance. In this case, measured with LCP, a web performance metric that measure time until the primary contents is painted on screen. So it's good, right? So we proved that best performance actually indeed improve performance practices, performance. But here's the one odd thing: oversized image. Oversized image blocked image, which is the primary content. So LCP should be increased, improved. But in this case, it does not improve the LCP. This is because document policy is still in its experimental state. So this is one thing we should improve later on. We also analyze other metrics, and we see the performance improvement. But yeah, for this detail, please see our papers. For the next test, we want to see how common those violations are. So we collected violations on Alexa top 1 million pages and grouped them into 5 clusters. So we sampled 100 pages from each cluster. And here's the result. This heat map shows a distribution of violations per page in 90th percentile. You don't have to read each number. It just shows violations of the best practices are very common in the wild. As you see, the color get darker as it goes down. More violation is found for lower length pages. This implies our approach will be more effective for the pages in the long tail of the web in terms of Alexa ranking, and which is likely to have a lot of performance issues. So wrapping up, we firstly identify the potential of the document policy for performance, for the basis of the performance solution, and answered our 2 initial questions. So best practice indeed improve performance, and such violation of such best practices are very common in the wild. For future work, we're going to build a system that dynamically detects the violations of the best practices on the fly with the help of the document policy. And then we'll do giving some feedback to content providers and improve the performance for users. We also identified a few challenges, like it is not easy to decide which best practices to apply and where. Also, interventions often introduce some usability issue. So we need to resolve this issue. And it will be the biggest challenge for us. Thank you for listening to my presentation.